Take a look around. The beams holding up the ceiling above you, the chassis of the car parked outside, the wiring inside the device you're using right now. Where exactly did all that metal come from? It is easy to assume that the industrial backbone of our civilization was recently pulled fresh from a mine. We tend to picture every new structure requiring newly extracted iron ore and raw bauxite. But look closer at this image of a massive scrapyard sorting operation. A huge percentage of the modern world is actually built by constantly recovering and cannibalizing the scrap of the past. Unlike paper or plastic, which degrade a little more each time they go through a processing plant, metals possess a unique scientific property: infinite recyclability. You can see that process happening here in this high-angle view of a smelting operation. Materials like steel and aluminum can be melted down and recast indefinitely, without compromising a single drop of structural integrity. Modern civilization builds its future by constantly repurposing its own remnants, moving beyond a simple reliance on extracting raw resources. This massive scoop of thousands of discarded aluminum cans shows where this material recovery loop is most visible, right at the consumer level. As this circular timeline maps out, the aluminum recovery loop operates at an incredible speed. From the moment you drop a can into a recycling bin, it can be melted, reformed, and back on a grocery store shelf in as little as 60 days. That same rapid recovery principle applies to the device in your pocket. The microscopic nodes mapped out here on a computer circuit board are rich with gold, silver, and platinum, all precisely extracted from old electronics to manufacture the next generation of smartphones and tablets. This localized material loop operates continuously, ensuring everyday consumer ecosystems meet daily global demand without exhausting untouched natural reserves. Moving from the devices in our pockets to the machines moving us around the planet, the transportation sector consumes an immense volume of raw material. Look closely at these automated robotic arms welding a complex vehicle chassis. The global automotive industry currently hits an impressive 81% recycling rate for steel, making reclaimed material the literal foundation of modern transit. And it goes beyond the highway. This exposed interior of an aircraft fuselage shows how the aerospace industry relies on specialized recycled aluminum alloys to drop the total weight of commercial planes. By utilizing these lighter alloys, engineers directly improve aircraft fuel efficiency. And because of infinite recyclability, they do this without ever failing the extreme fatigue resistance and safety specifications required for flight. The speed, safety, and economic viability of global travel are directly supported by our ability to continuously repurpose legacy scrap metals. Zooming out even further to the city scale, we find the massive structural foundations required to hold up commercial skylines. As you can see with these massive steel beams being hoisted by a crane against the skyline, recycled steel is put to work because it provides the exact same load-bearing capacity as virgin steel, while cutting total construction costs by up to 25%. Then there are the hidden utilities running beneath the streets and through the walls, miles of recycled copper powering our telecommunications and electrical grids. This dual bar chart compares copper costs, showing exactly why industries prefer reclaimed wiring. Recycled copper retains a massive 90% of its original value post-recycling, allowing builders to avoid the volatile costs of virgin extraction, while preserving perfect thermal and electrical conductivity. Our towering megastructures and instantaneous communication grids rely so heavily on these specs that building them would be economically impossible without integrating recycled metal. Avoiding the extraction of virgin ore generates massive, measurable energy conservation across the global industrial landscape. To understand the scale of that energy conservation, look at this single aluminum can pulsing with electricity. Recycling just one of these saves enough energy to power a standard light bulb for a full 20 hours. However, this global industrial cycle doesn't happen automatically. It is completely dependent on decentralized, local processing facilities to gather, sort, and process the initial raw materials. To keep that specific supply chain moving here in Georgia, you need a trusted local partner like Taylor's Junkyard. Facilities like Taylor's provide the exact commercial solutions shown here, offering roll-off dumpsters, standard scrap recycling, and specialized demolition services to handle large volumes of waste. Actively utilizing a trusted local scrapyard is the vital step required to turn unused local waste into the permanent backbone of a cleaner global future.